Physics is the study of the universe, which is tantamount to saying physics is the study of everything. Needless to say, studying everything can be quite the intimidating task, but physicists are clever. They realize that the study of everything could really be boiled down to the study of the few fundamental ingredients which go into building everything else. Take, for example, a star in the night sky. Like others before them, physicists wondered what they were and came to realize that, contrary to popular belief, they were not diamonds in the sky, but rather hot, luminous gas. Zoom in and you'll see that each star is in fact comprised of chemical compounds called molecules, which are themselves composed out of atoms of the elements of the periodic table. Zoom in even further and you'll find that each atom of an element is itself formed of a hard nucleus containing protons and neutrons surrounded by a cloud of orbiting electrons. For a long time, scientists believed that these were the fundamental constituents of all matter: protons, neutrons, and electrons. Upon even further magnifications, however, it has been realized that, while electrons constitute indivisible, fundamental particles, protons and neutrons are in fact made up of even smaller constituent particles called quarks. A proton contains 2 up quarks and 1 down quark, while a neutron contains 1 up quark and 2 down quarks. A particle composed of 2 or more quarks, like a proton or a neutron, is called a hadron. Remarkably, there are even still more fundamental particles which go into forming the stars we see in the night sky. Particles called gluons hold quarks together inside hadrons through an interaction called the strong nuclear force. Over time, as a star ages and exhausts its resources of hydrogen and helium, it begins to decay radioactively through an interaction called the weak nuclear force, facilitated by particles known as the W and Z bosons. In fact, the only reason we can see stars to begin with is because they emit particles of light called photons, which are released as byproducts of the electromagnetic interactions occurring between charges in the star. When all is said and done, physicists have determined that there are 17 indivisible fundamental particles which are responsible for producing almost all the matter we observe in space and facilitating almost all the interactions between matter through the 3 fundamental forces: electromagnetic, strong, and weak. Those are a couple of big almosts, but that's for another video. These 17 particles form what is called the standard model of particle physics, which, despite its shortcomings, is quite handedly the most complete, all-encompassing model for understanding the physical world. Miraculously, physicists can understand the physical properties and interactions of any system cooked from a recipe of standard model ingredients simply by understanding the properties and interactions of the underlying particles. Thus, we went from having to worry about everything to having to worry about 17 different things. Not a bad magic trick, huh?